Hello and welcome to the second part, to the security aspects of the M2M ecosystem. We'll talk about the keys, certificates, and the algorithms. So the certificates hierarchy, starting with the root certificate of the GSMA. It's called the root CI, so this root CI certificate, the CERT CI ECDSA. ECDSA stands for the elliptic curves DSA algorithm. And yes, so it's always elliptic curves. So the cryptography is based on the elliptic curves in the EUSSC world and the remote SIM provisioning world. And therefore, you'll find this EC before the algorithms. This certificate is a self-signed certificate issued by the GSMA CI, and it's a trust anchor inside of the EUSSC or the server side. So the private key is kept secret, so this certificate is publicly available on the GSMA webpage. The GSMA issues certificate to the EUM, the EUSSC manufacturer, and so this certificate is called as EUM certificate set.eum ECDSA. The EUM itself issues certificates for all of the EUSSCs under its control. And this certificate is in the EUSSC is called the CERT ECASD. So for the for the security domain, which is the controlling authority security domain of the EUSSC. This concept of the security domain comes from Global Platform as well, and you can check the specifications for this. And the ECKA stands for the elliptic curves key agreement. So this is just referring to the algorithm itself. Okay, this certificate is a part of this EUSSC information sets and is used there. Another certificate issued by the GSMA CI is the SMSR certificate. It's this CERT.SR ECDSA. And yes, it corresponds to the private key of the SMSR, so same as the EUM certificate corresponds to the private key of the EUM. The SMDP certificate is again issued by the GSMA, so it's issued only to the certified entities, so for all three entities of it, so EUM, SMSR, and SMDP. And the DP certificate is corresponding to the private key of this DP. The format of the certificates, so for the EUM and for the GSMA CI is the X509 certificate format, which is commonly used like in the standard Windows use case. But for the other certificate, it's a bit different. It's called GP format or the ISO-based format. So there are some specific text length value format and the specific tag for the certificate. So it's more used in the smart card area. Okay. And these certificates, so they are exchanged between these different entities. So in the way I will explain later. Let's take a look on the keys and certificate settings for the M2M, especially on the platform settings. Settings for the SMDP and the SMSR, which are required. What is needed to be inside of the SMDP and SMSR to perform the profile download and the other operations of the remote SIM provisioning. Okay, first of all, is the CI public key, so which is a part of the CI certificate, which is the trust anchor inside of the subscription manager, used to verify the validity of the EUM certificate. And if you know the validity of the EUM certificate, so you will subsequently know if the EUSSC certificate is authentic as well. Okay, just a second. So just to mention, so that the CI certificates, so without this certificate, so nothing will work, and without this other certificate, so the whole cryptography process will not work as well. So you cannot just create your own certificates and try to access some commercial devices with commercial EUSSCs, because if you don't have this according certificate on your system, so it will not work because of this trust anchor. Okay, what else is needed? So for sure in the SMDP, there's a need for this SMDP certificate for SMDP authentication and key establishment, which is used on the side of the profile download. The SMSR certificate is used for the SMSR authentication and the key establishment during the SMSR change procedure. The EUM certificate maybe is exchanged early in the earlier stage, can be stored then on the server side. And this certificate is issued to the GSMA accredited EUM, which can be used to verify EUSSC certificates. So the SMDP and the SMSR can verify this certificate. Using this root CI certificate, this certificate from the GSMA, this one. And this can be stored just as a part of the storage. It's not needed for the initial steps, but in the future it will be needed to check the EUSSC certificate. Okay. What is required for the EUSSC? What are the EUSSC settings to communicate with the SMDP and the SMSR? Again, you will always need this trust anchor. So it's the GSMA certificate, which is available on the GSMA page. See a public key. It's used to verify the validity of the SMDP and the SMSR certificates. So the EUSSC checks if the certificate received from the SMDP and the SMSR, if it's authentic. And therefore it uses the certificate from GSMA CI. So it checks who signed this certificate. If it's the same GSMA CI, which is already the trust anchor inside of the EUSSC, then everything is fine. If not, then it's something else. Yes, secret key, it's actually part of the server systems as well. So for sure, you will need the secret key to be a part of it anyway. So to complete the whole procedures to start the authentication of the EUSSC and the key establishment anyway. It corresponds to the EUSSC certificate, the CERT ECKA certificate for the EUSSC authentication key establishment. So the public key on the certificate will be shared. And this certificate is a part of the EUSSC information set, which is actually stored on the SMSR and also potentially on the EUM level. And this is verified by the public key of the EUM certificate. So you have kind of a chain. What are the operator settings? Operator belongs to the server side as well. So the operator will have the OTA keys, which are the keys for the profile update. The mandatory set of the keys is the SCP-80 keys. So first for the encryption, and then for the authentication. So potentially, the MNO can use the SCP-81 keys or any other proprietary keys as well. But this part is mandatory. So please try to not mix these different types of keys. There are three types of keys. The one type of keys is this classic OTA keys, which are used by the operator to access the profile data or change something inside of the profile. So these keys are used for the remote file management and remote application management. Okay, this is the specific set defined by the MNO and used by the MNO only. Okay. Then there are additionally the keys which are used for the network access. So network access application keys, and they are used for millinage, 2-hop algorithms, or any whatever is used to access the network. So the network keys, they are not mentioned here. And the other keys, which was previously on the previous slides, were mentioned. So these are actually there's remote SIM provisioning keys. This remote SIM provisioning keys, they are used for the actual remote SIM provisioning, the profile download, and the security around the encryption, enabling and disabling. Okay, I hope it's clear now. So let's talk about this key establishment. What is used for this is so-called scenario 3 from the global platform specifications, with a mutual authentication part included. It is used for the profile download installation and refers to global platform card specification amendment E, which is security upgrade for card content management. Amendment E includes new cryptographic schemes based on elliptic curves, and ECC specified for public key ECC is specified for public key cryptography to enable compact data structures. Part of it is also enhanced security mechanisms that are provided for the tokens and receives, which are used in the delegated management. So yes, the DEP, which are used for the protection of load files, and the confidential setup of secure channel keys, so-called scenario 3. In our case, the scenario 3 is complemented by the SMDP authentication, which was initially not planned. Okay, let's talk about this scenario 3 part. So this mutual authentication on the example of the key establishment between the SMDP and the EUSCC. We will skip this SMSR part, so where we have again this key establishment in a similar way, and assume so that this part of the protocol has already happened. There is the secure channel protocol established, and start with this part. So I'll go in this less detailed. Okay, let's take a look on what is inside of the SMSR and the M2M device with the EUSCC. On the SMSR, we have this root certificate, the trust anchor, and the SR certificate itself. For sure, there are private keys as well. On the EUSCC, we have this root anchor again, and so root certificate is a trust anchor again, and the secret key of the EUSCC, which is now required, will be later required for this key establishment part. Okay, you see that there is this certificate is used to verify the SR key and establish the secure channel. This will be the SCP 80 or 81. Let's take a look on the SMDP. It will have again, similar to the SMSR, it will have its own certificate and the trust anchor. It will have the profile on it and the EUSCC information set received by from the SMSR. Part of this EUSCC information set is this certificate of the EUSCC, corresponding to the secret key of the ECASD. So, yes, EUSCC secret key. Okay, so we'll exchange some data between the device and the SMDP. And the SMDP sends its certificate for the authentication. This certificate will be verified by the GSMA CI certificate. If its goal goes fine and yes, working, so the certificate is authentic, so then the SMDP will create its own key pair, so which is ephemeral key pair, so the EPK and the ESK, so the DP, and will send this public key to the EUSCC. The next step, the EUSCC will use this public key of the DP. In the next step, the EUSCC will use this public key of the DP and will will create this shared secret using this secret key and public key. This shared secret is used as an input for the key derivation function, which is used to derive the key set for the SCP-03 protocol, 03 or 03T protocol. So, and this protocol will be a symmetric one. Currently, we are using the asymmetric cryptography to establish the key set. But after this key derivation, you will have symmetric keys, which are using AES. And so, yes, to establish the secure channel. What is happening on the server side is that the secret key is used together with the public key of the EOSSC to derive the shared secret. So, and since it will be the same shared secret, so there will be same keys derived using the key derivation function. And then with this SCP-03T protocol and this new secure channel established, so the SMDP can encrypt this profile and the download profile process can start. And the encrypted profile can be downloaded to the EOSSC, and since the keys are equal, same, the EOSSC can decrypt this profile and get the data, not the SMSR. Okay. I hope it's clear. Let's take a look on the secure channels. The secure channel on the ES5 between the SMSR and EOSSC, or actually the ISTR, is the secure channel. Yes, for the platform management commands of enabling, disabling, and deletion of a profile. It's using the key set for the SCP-80. So establishing the key set can be also as an algorithm can be used the SCP-81, which is optional, but normally for the small commands enabling, disabling, and deletion, so SCP-80 is sufficient, or SMS actually is sufficient. It's used to transport the profile management functions to the EOSSC. And it's used for the remote OTA communication, SCP-80 SMS, okay, or CAT-TP as it defined in the specifications, but CAT-TP is not used in the real world. And it's defined in the ETCTS 102.225, and it's defined in the ETCTS 102.226. So SCP-81 or HTTPS is defined in the 102.226 and Global Platform Amendment B. Okay, let's take a look on the secure channel on ES8 between the SMDP and the ISTP, actually. So you can see it's now tunneled through the SMSR channel, and it's used for downloading installation of a profile, the profile management commands. So with the secure channel between the SMDP and the SMSR, through the secure channel between the SMDP and the SMSR on the ES3, secure channel between SMSR and the ISTR on the ES5, protected by profile management credentials, SCP-03 or SCP-03T secure channel. You remember, so the Amendment E for the key establishment and Amendment D for the actual SCP-03T secure channel protocol 03 is defined by global platform as well. And the key derivation process is based on the public key of the EOSSC. On the ES6, the secure channel is between the MNO and its OTA platform and the MNO-SD. So this is the specific security domain inside of the profile. And so as you remember, so the operator talks to his profile actually. Yes, it's used for the remote file and application management commands for the RFM and remote application management RAM. So it's using the key set SCP-80 as mandatory, so optionally SCP-81 or any other key sets. So yes, for the remote communication using the SCP-80 SMS, defined in ETC 102.225 and 226. SCP-81 defined in 102.6 and Amendment B. And the profile management commands for the connectivity parameters update and policy rules update on the ISTP. Let's take a closer look on the keys and certificates and try to assign them to specific operations. For the registering of the EOS information set, what is used? It is the GSMA CI certificate is mandatory, and the EUM certificate. This will be verified, as you remember, by the GSMA This will be verified, as you remember, by the SMSR. For the auditing of the EOSC information set, also the EOSC capability audit, so the SCP-80 key set is required, is mandatory. Okay, for the download and installation of profile, the most certificates and the keys are required, almost. So yes, there are SCP-80 key set, the SCP-81 key set may be required. So yes, especially, so it's mostly used, so the SCP-81, so the download using the HTTPS because of the big amount of data of the profile. So on all entities are using the GSMA CI certificate to verify the authenticity of the certificates. The EUM certificates is used to to verify the EUM and subsequently the EOSC certificate, and the SMDP certificate is used to show that it's an authentic SMDP talking to the EOSC. For the enabling, disabling, and deletion of the profile, only the SCP-80 key set is required. For SMSR change, yes, here again we use the SCP-80 key set, so as soon as they are established. For the key establishment, we are using the GSMA certificate of the SMSR, yes, and the private keys for sure. So same as for this, for the key establishment, for the download of the profiles with the private key as well. Yes, and EUM certificates as well for the USCC verification. The content update of enabled profile by the operator requires the MNO specific SCP-80 key set. This SCP-80 key set is the EUSCC specific on the ISTR. And optionally, so here we have this MNO specific SCP-81 key set. What kind of security is used on the, for the off-card entities? So from the server side. On the server side. So we have here the SOAP messages between function requester and function provider. They can be synchronous and asynchronous. So sending the request and response between the function request and provider. The mutual authenticated transport level security is the TLS 102. Sorry. Server-side authentication and WS security, so using username token profile and X509 certificate token profile. Yes, here you have this example of the off-card security with asynchronous example with callback, which is, yes, we were using the TLS 102 for the authentication of the entity to servers. The client certificates for ongoing, for outgoing connections are used. For the authentication of the entity to clients, the TLS server certificate for incoming connections are used. And here we have the case when the client, the functional requester, calls this asynchronous method, so to the asynchronous web service. Starts the TLS service with its processing as soon as it's completed, so then it sends the response. So as soon as it's completed, so then it's waiting for the callback service and then sending the response. So request, send response, and then there is a confirmation, so going back to the callback service. This is an example with asynchronous use case. Okay, so this was a security part in an almost brief overview. So, but it's if you want to go deeper, so then you have to implement all of the commands. Otherwise, it's difficult to just in theory to understand what happens. But this is I think a good starting point from the theory. So to understand what is going on, what is behind. So my next step is, yes, to summarize or to verify your knowledge. Let's start with some questions. So if you have good answers, so then you're well prepared. How is the profile secured? What is required? So what are the steps? And what are the protocols? So are they symmetric, asymmetric? So which keys are used for the security? How is the profile secured? So where is the SMS defined in terms of the SMS, not in general? So yes, for sure. So there are 3GPP specifications or RSP specifications actually. So there are some parts, but now here related parts of this SCP-80 protocols. So where it is defined. Which protocols are mandatory for the EUSSC to be implemented? Okay, on the server side, so there are a little bit more. So on the EUSSC side, so there's only some protocols are mandatory. Where is the SMSR certificate used? And the last question, how is the key establishment procedure defined? What is required for this key establishment procedure? So you remember the different steps of so using these different certificates, verification, and then the key establishment itself. Okay, so take your time, take a look back, so if it's required, and then from my side, so we finished this part. So we assumed that there's a basic knowledge for this, so the M2M architecture and at least the profile types. So we learned the RSP procedures and security aspects. And what I can recommend, the next steps for you is to take a look on the international standards and the certification. So which standards are relevant, what is required, and what is the certification process for this. And then from my side, thank you very much for your attention and see you next time. Talk to you next time in the next parts in the consumer devices or in the other parts of the RSP remote SIM provisioning. Enjoy it. Thank you. Bye.